Good morning class and welcome to another lecture on sustainable energy technology. Today we will discuss the impact of fossil fuel based energy production and usage on global warming and climate change. Most of fossil fuel based energy sources emit CO2 as well as other types of gases like methane and nitrous oxide, which are global warming gases. By global warming gases, we mean that these gases, when they enter the atmosphere, has the ability to trap infrared radiation that is emitted from Earth's surface towards space. As the gas concentration builds up, these gases trap more and more heat into Earth's surface and lower atmosphere, and as a result, the Earth's surface heats up. This is called the global warming effect caused by these greenhouse gases. The impact of this effect is a steady rise in Earth's mean surface temperature over pre-industrial average, as well as other associated effects like increased storms, changes in weather and climate patterns, loss of sea and land ice, etc. These impacts are very detrimental to both the environment and the future of human society as a whole, and this is a serious concern regarding the sustainability of fossil fuel based energy sources and is also a motivator to move to a non-fossil fuel based or at least a non-CO2 emitting system of energy technology as quickly as possible. So we will look into this in today's class. First, in this slide, the scientists Houghton and Nassikas, so this refers to a study by scientists Houghton and Nassikas in 2017, which makes an inventory of the total CO2 and other greenhouse gas emissions that have happened around the globe from 1990 onwards on a per year basis. So here in 1990, we see the total greenhouse gas emissions was around 35 gigatons of CO2 equivalent. Here the y-axis has an interesting unit which is called CO2 equivalent. What it means is our human energy, land use and industrial work emits several types of greenhouse gases: CO2, methane, nitrous oxide, chlorofluorocarbons, etc. These have different types of efficacies when we think about how much they can trap heat in Earth's atmosphere. So what we do therefore is that we convert the efficacy of one gas in terms of another gas which is considered as the standard. So suppose CO2 has certain ability to trap heat emanating from Earth's surface and methane has 2 times that ability. What it means is emitting 1 kg of methane will have the same impact in global warming as emitting 2 kgs of CO2. So 1 kg of methane is equivalent to 2 kgs of CO2, and that is what CO2 equivalent means. So 20 CO2 equivalent kgs of methane means a certain amount of methane has been emitted which is equivalent to 20 kgs of CO2 emissions. Similarly, a certain amount of chlorofluorocarbons have been emitted which is amounted to certain kgs of CO2 emissions. So CO2 is the standard based on which all other gases global warming efficacy is considered, and from that CO2 equivalent values are calculated. Here all the blue colorations are CO2 emissions from various types of human activity. The largest section, the dark blue coloration, is CO2 emissions from energy sources. The light blue or medium blue coloration is CO2 emissions from international transport, which is being kept separately because it does not go into any specific countries' CO2 emissions inventory. So international transport in this case means things like international shipping, international flights, etc. Then there is CO2 emissions from other human activities not associated with energy technology. If you remember, in the previous tutorial class, we looked at how energy technologies like a coal power plant emits a lot of CO2 per day. And so the CO2 based energy technology here primarily includes power production, heating applications, as well as domestic transport applications. The medium blue CO2 is international transport, and all other sources are clubbed into non-energy. There are two things that you can see. Both in 1990 and 2015, CO2 emissions are the largest contributor to global warming greenhouse gas emissions in absolute terms, in terms of their ability to warm the atmosphere. Of the total, around 35 gigatons of CO2 equivalent emitted in 1990, more than 25 gigatons was CO2 emissions directly. Similarly, in 2015, the total CO2 equivalent emissions worldwide was around 50 gigatons, of which around 35 gigatons was from direct CO2 emissions. But CO2 emissions is not the complete picture. We also have methane emissions from various sources. The dark brown or the dark green is the methane emissions from energy sources. This is primarily because CO2 methane, as it is being extracted from underground reservoirs, transported or stored, can leak out into the atmosphere. So these methane emissions from energy sources is primarily through leakage in the natural gas transportation systems. Methane is also emitted from the agricultural sector. So when you think of farming like rice cultivation, tea plants, etc., which requires the agricultural fields to be under water for long periods of time, there natural biological fermentation and degradation processes in inundated floodplains cause a lot of methane emissions. Similarly, livestock in their digestion processes also emit a lot of methane, like cattle, sheep, goats, etc. So methane emissions from agricultural sources is a large proportion of the human induced methane emissions in the world today. Similarly, waste products, when they decompose naturally in the waste dumps throughout the world, are also producing a lot of methane through fermentation kind of processes. So these are the sources of methane emissions. After that, the third most important contributor in greenhouse gas emissions is nitrous oxide, one of the gases in NOx. NOx contains N2O, nitrous oxide, NO and NO2. N2O is a potent greenhouse gas, and its primary source is actually agriculture. So whereas energy technologies primarily emit NO and NO2, agricultural activities produce N2O. How? Many of the fertilizers contain nitrogen compounds like urea. When urea is being produced or when they are being put into fields, this urea slowly decomposes to produce nitrous oxide, and that is the largest contributor of N2O emissions in the world. After that, we have chlorofluorocarbons, which are basically fluids that are used in air conditioning systems. These are very potent greenhouse gases, and hence we have a contribution from them. And this together represent the total greenhouse gas emissions in worldwide today on a per year basis over the last 25 years. Okay. Beyond this, there is certain other emissions related to land use changes. So for example, if a forest is cut and agricultural fields are put into its place, the ability of the forest to draw down CO2 is destroyed. So an area of land which was first absorbing CO2 through a lot of green plants, green trees, etc., has now been converted into agricultural fields which cannot absorb as much CO2. So there is a net increase in CO2 emissions in the world because of the loss of that primary forest. And this kind of land use changes contribute to indirect emissions of CO2 because the world is less able to absorb the CO2 that is there in the atmosphere. So these are land use changes which contribute another 10 gigatons, 10 to 15 gigatons of CO2 due to human activity. Okay. Now, if you look into the greenhouse gas, where from which area greenhouse gases are being emitted, you will see the largest contributor, 1/4, is electricity and heat production. So electricity generation and heat, furnaces, boilers, etc., heat production. The second largest is agricultural, forestry and land use based changes. So agriculture produces a lot of methane, nitrous oxide, land use based changes, elimination of forests, etc., also contribute a lot of greenhouse gases. So these two together contribute almost half of the total greenhouse gas emissions. Then you have transportation sector and industrial sector. In industries, particularly steel making, iron smelting, cement industries, brick kilns, etc., emit a lot of CO2 in their basic process technology. For example, in steel making, you need a lot of carbon to convert iron into steel. And part of that carbon is actually lost as oxidized and lost as CO2. So steel making is inherently CO2 intensive technology. Similarly, cement and several other industrial systems. So these contribute 21% of the total greenhouse gas emissions, followed by transportation, trucks, cars, two-wheelers, aircrafts, etc., and other types of energy-based technology applications. And buildings contribute the remaining 6%. So if you look at energy and industrial work, today's world, that contributes around 75% of the total greenhouse gas emissions in the world. Okay. Now, if we look at region-wise distribution and we divide the decades from 1950 to 2015 on into two zones, one is 1950 to 1980, another is 1980 to 2014, till which the data is there for in this plot. We see that in the 1950 to 1980 decades, the largest contributor of CO2 emissions was United States, European Union and the then Soviet Union. So United States, European Union and Soviet Union contributed most of the CO2 emissions in the world because they were the developed regions of the world. The rest of the world was relatively undeveloped in their energy infrastructure, industrial infrastructure, and hence did not contribute significantly to CO2 emissions. Now, if we move to the next 3 decades, 1980 to 2014, here we see that firstly, overall emissions from each area has increased. So like US was around 110, now it's around 180. EU was around 80, now it's around 120. But if you look at the rest of the world, for example, China, India and the rest of the world clubbed together, African nations, Latin American nations, Southeast Asian countries, they are contributing a significantly larger fraction of the CO2 emissions as their development has gained pace. Compared to that, US and EU, still very large, are relatively grown at a lesser pace because they have been developed for a longer period of time. So what we see is a change in narrative of where the total CO2 emissions is coming from. Increasingly, Asian countries, Latin American countries and now African nations are beginning to pick up and increase their amount of CO2 emissions. And now if we look at the country profile and look at India in global context, and here we will look more on not the total CO2 emissions in per year, but total CO2 emissions per person per year. So if a country has 100 million people and this 100 million gigatons of CO2 emitted, then 100 by 100, 1 gigaton per person of CO2 is emitted per year. So that's the idea of CO2 emissions per capita. So this kind of looks at what is the energy CO2 intensity on a per person basis. Okay. And we see that North America, which includes Europe, Canada and Mexico, has the highest per person CO2 emissions in a year of around 10 tons of CO2 emitted per person per year basis. So this is what the green bars are. Eurasia, which is the countries of Soviet Union primarily, is next at around 8.5 tons of CO2 emitted per person per year. Then we have China. So China has increased in its CO2 intensity to a large extent in the last 30 years, and now it is almost close to what USSR was. So around 7.5 tons of CO2 per capita. Middle East is also a large emitter of CO2, around 7 tons of CO2 per capita. Europe, while being far more developed, almost as much developed as US, has much lower CO2 intensity per capita because they have aggressively moved into renewable and sustainable energy technologies, which decreases the CO2 intensity of their industrial and energy production systems. So they have around 5 tons of CO2 emissions per capita. Now, if you look in India, India has very low CO2 emissions on a per capita basis, around 2.5 to 3. And it's close to African and Latin American nations, which are still relatively undeveloped compared to European, Eurasian, North American, or even Chinese economic systems. So their per capita CO2 emissions in India is also quite low. And we see that this per capita CO2 emissions is low because of lower development rather than improvement in renewable energy by looking at what is the CO2 intensity of electricity generation. So electrical energy is generated in terms of kilowatt hour basis. So how many grams of CO2 is being emitted per kilowatt hour of electricity generated in these regions? And if you look into that, you see that for India has the largest amount of CO2 being emitted per kilowatt hour of electricity generated, around 11 or 12 grams of CO2 emitted per kilowatt hour of electricity. And this is the largest compared to all other regions of the world. For example, North America just has around 5.5 or 6 grams of CO2 emitted per kilowatt hour of electricity. Europe has even lower, around 4.5 kilowatt hour of electricity, grams of CO2 emitted per kilowatt hour of electricity. Okay. China has high intensity. So China is very close to India in that context. Russian Federation and the countries of the erstwhile USSR are also at high CO2 per capita. Okay. So these countries, India, Eurasia, North America, have not invested, Eurasia, China and India have not invested significantly in abating the CO2 intensity of their energy production. Okay. So even though they are using lesser electricity than say North America, which is using a lot of electricity, so the absolute CO2 numbers are much larger, their amount of CO2 emitted is still significantly large than what would we expect. Okay. So what it means for India is India, if it is to develop well and sustainably over the next 20-30 years, must drastically decrease this CO2 intensity of electricity in grams of CO2 per capita from around 12 to around 4 or 5 at a minimum, so that its development process is not also causing a large CO2 emissions on per capita basis in the next few decades. And here we look at the CO2 emissions from the Indian energy sector in 2019. Again, International Energy Agency figures from a report that was published in that year. And you see, this is the metric tons of CO2 emitted in that year, 2019 year. We see that the power sector is the largest contributor of CO2 emissions with around 1100 metric tons of CO2, of which coal-fired plants, like coal power plants, are generating the bulk of CO2. And as we saw in the tutorial lecture, that generating a certain amount of electricity from coal-fired power plants produces a lot of CO2. Okay. So one of the strategies that Indian government is now adopting and will be adopting over the next few decades is to slowly replace these coal-fired power plants with renewable energy based power generation systems, or more efficient natural gas based power generation systems, or nuclear based power generation systems, so that the contribution of power to the CO2 emissions decreases from its high value currently. The second largest contributor is industry. As you can see, iron and steel and cement produce a large quantity of CO2. These are often called hard to abate sectors because their processes require carbon. Okay, and that oxidizes to form CO2. So here we will discuss there are possibilities of using CO2 capture and storage technologies in order to decrease their CO2 footprint in India, and those are kinds of the issues that we will be discussing in the latter half of the class, how to capture CO2 so that these kinds of industries where you cannot easily shift from a carbon based source to something else can be tackled. Okay. Then you have transportation sector, the third largest contributor of CO2 emissions in India, trucks being the largest, then 2 to 3 wheelers, then cars, then other types of transportation sectors, transport vehicles. And here also we need to move from, we need to increase our fuel efficiency standards. We may need to move from fossil fuel based petrol, diesel to biofuels or EV based systems, and use those kinds of transitions to decrease the CO2 footprint of these transportation sectors. The fourth sector is buildings, heating, cooling applications, lighting applications. So the HVAC systems, as we call it, heating and cooling systems. So these are the next section, and then you have the other energy and agricultural systems. Okay. So that's kind of the structure of where the CO2 is coming from in the Indian context, and hence how to some ideas of how to mitigate each of these sectors, which we will discuss in more detail later in the class.